I was just doing I was on step 1 of 4.
Oh.
A little bit slow.
Hi, everybody. So I'm going to talk about Rust today. These steps here are completely optional. If you would like to follow along interactively, that is a great thing to do, but feel no pressure to do so. That's even better. Okay, so I'm going to go ahead and get started. One quick logistical point. I hope and anticipate that pizza will arrive at one point, and at that time, I think we'll all maybe take a couple minutes, and I and you can eat some pizza. So my name is Paul. I work at CCV, and today we're going to do a quick introduction to the Rust programming language. So what is Rust? I like this quote a lot. It's at the beginning of this book. A lot of the examples that I'm going to go through are from this book. But Rust is, I guess, Rust is a sort of lower level systems type language, but it's really targeted at a more kind of general audience. So whereas someone who would have written something in C or C++, now maybe they can write it in Rust, and Rust is, I would say, a lot friendlier than certainly C++. This book is phenomenal, by the way. I highly recommend. It's freely available online. Okay, so Rust is a compiled language. It is statically typed, and it is strongly typed. It's also fast, and I hope to convince you that it is also fun. Statically typed and strongly typed is a little different than, for example, if you frequently work with Python or R or something like that. So statically typed means we know the type of every variable when we compile our program. Strongly typed just means that it is not easy to convert things from one type to another. So even something like doing math with a float and an int, we need to explicitly handle that. So in terms of the design, it's functional-ish and it's imperative-ish. It's not explicitly object-oriented, but we'll talk about some kind of elements of Rust that can make it feel a little bit like object-oriented languages, although there's no concept of inheritance. So without further ado, here is a simple Rust function. Oh, I should also mention, doing this in a Jupyter Notebook context would be super, super atypical. Nobody uses Rust in notebooks. I just do it because it's very convenient for presentation. So you would just work in Rust at a normal text editor, VS Code or whatever. But yes, without further ado, here is some Rust code. So this is a function, computes Fibonacci numbers just by doing kind of the standard iteration and temporary variable. A couple of things to note. So we have type annotation, but only at the function boundary. Another thing to note is that we have to explicitly call out that these variables, so A, B, and temp, are mutable. So types in Rust are immutable by default. So if you don't say mute, then it's going to assume it's immutable. The other thing to call out is we need to specify the return type. So this little right arrow notation means this function is going to return I32. And again, we don't have type annotation other than at the function signature. And please, anyone, feel free to interrupt or ask questions anytime. Okay, so Rust was developed at Mozilla, actually, and they developed it to work on part of their browser engine. So that's kind of that was kind of the motivation behind. We wanted a very fast, high performance language that also handles concurrency well and deals with memory safety issues. And we'll talk more about that in just a second. I said this. So why might you want to use Rust? Well, again, I hope to convince you that it's very fast. It's memory safe, which we'll talk about more in a second. It's also got, I think, better tooling than any other language that I can think of. And when I talk about tooling, I guess I mean the package manager and the ecosystem around that. I think I've never seen, we'll talk about Cargo, the package manager, but I've never seen something that just seems to perform so well kind of out of the box. I said it's fast. So Rust is fairly young, but it's kind of starting to grow in terms of adoption. So I don't know if folks have used the Polars package in Python, but Polars is actually it's a Rust crate, and it is it's only ported to Python via like a C foreign function interface, but Polars is all Rust. Yeah, so the other point, and we'll see more about this in a second, but Rust has a very interesting ownership model that ensures memory safety. This is important for lots of reasons, but one of them is that memory safety bugs, so like dangling references or double freeze, null pointers, that kind of stuff accounts for something like 70% of critical vulnerabilities in a lot of the stuff that we used. Oh, the pizza's here. Let's take 10 minutes maybe, because we all want pizza. So let's pause here, and yeah, let's pause here. Oh, and if folks are interested, the instructions for how to follow along are pasted in Slack, so they're in the DSCoV Slack.
Do you recommend always using polars over pandas?
Oh, that's a great question. Would I recommend always using polars over pandas? I don't think I would say that just yet. I think pandas has been around long enough that it has a lot of functionality that Polars does not yet have. I think Polars is probably faster for certain things. It's definitely faster for certain things. Yeah, I don't know. Paul Shu, you've used Polars and Pandas, right? Do you have any advice?
Yeah, I would say no. It's used for kind of if you have like huge data but simple operations, you can do that. But if you have a smaller data set but want more functionalities, you probably still need to stick to Pandas.
Pandas is so feature rich, it's kind of hard to compete. But I'm going to lead by example and have some pizza.
I will follow your example, Paul. Don't worry, Paul. We follow our leaders. It's the way. It is the way.
People are not hungry. Yeah, what do you do? They're not hungry. This is kind of chicken. One of the tracks from Mustard Bite? Yeah.
Oh, you guys are so fancy. Oh my god. I am brute force all the way. Do I want that?
The same as that.
No, but this one's for me.
The Zoom link? It's in the ARC. I'll send it.
Send it to Stey. I think I prematurely grabbed it. It's different than what we sent to the CCV like now.
It shouldn't be. It's this guy.
Thank you for setting an example, Paul.
Yep.
I just saw that too. Did you just see that?
Oh, I just got some feedback from people. Did you happen to mute your Zoom?
Yep.
So your computer needs to be muted, but not Zoom, so no one on Zoom can hear you.
Okay, thank you.
As long as your computer's muted and your Zoom is not muted, it's fine. There won't be any weird noise.
Okay.
Thank you.
Okay, so please continue eating and getting pizza, and I'm going to try and go through these slides. So I mentioned before, but I guess this tries to emphasize the point. These are the rankings of Stack Overflow's most loved versus most hated languages, and for the last 7 years, Rust has been at the top of this kind of ranking. So people really enjoy working with Rust, and I think a piece of that is kind of the language itself, but also, like I mentioned, it has really great tooling built up around it. Okay, so its similarities, it's probably most similar to C++, and we can see that kind of in the, sort of at the syntactic level. But it also has the same goal of kind of creating zero-cost abstraction, so the notion that if you don't use something, you don't pay for it. It's also got some aspects that kind of remind you a little bit of elements of Haskell. So it's it's got a lot of functional features. It's got immutable types. It's got this concept of traits, which we'll talk about in a few minutes, and that's kind of analogous to type classes in Haskell. So how is it different from other languages? Well, I mentioned it before, but Rust has a concept of ownership. And that's essentially how it manages memory. So it determines when a thing is created and when it's destroyed, basically. So here is what looks like a fairly innocent enough piece of code, and it does not work, and we are sad. Part of Rust's really nice tooling is very, very informative error messages. So if you look here, it actually tells us, it really tells us exactly what the issue is. So it says, so we're trying to assign the S1 string on top to S2. So that would work in most languages, right? It doesn't work in Rust here because, for a few reasons, but basically we are moving the value of S1 here. So this line here actually moves the data that S1 holds onto S2, and then when we try and do something with S1, it complains because, hey, that's not here anymore, we've moved that value. So what to do? Well, one thing that we can do is just make a copy, and that will work. So if we use the string type implements the clone trait, and we'll talk about traits later, but so we just say .clone, and then that's going to allow us to run this, and it'll look more like it would from Python or any other kind of programming language. So we usually want to avoid making copies, right? We usually kind of don't want to make copies unnecessarily. So one way that we can do that, and this is true in other languages too, is we can have references to data. So we can pass data around, and the sort of Rusty convention is to call that borrowing. So we use the little ampersand the way you do in some other languages to denote that something is a reference. And then when we actually use the reference, we also use the ampersand. If there's any questions or anything, again, feel free to interrupt. So again, types in Rust are immutable by default. So if we want to have a function, for example, that takes a reference to a string as an argument, and then we want to modify that reference, which is to say, add something, append to that string, Rust will be reluctant to let us do that. But again, it tells us it hints at the compiler's error message kind of hints at how we would fix it. So in particular, all we need to do is say we declare S as mutable using the mute keyword, and then we update the function signature to say that some string is a mutable reference. So this is the annotation that indicates mutable reference. And that works kind of the way we would expect. We can also have multiple references. can we make it a little bigger? We definitely can do that, Ashok. Thank you for asking. Is that better? Yeah. Good. So we can have multiple references to the same piece of data. So here we have our string S. We can take the reference to that and call that R1. We can take another reference, call it R2, and that's going to work just kind of how we would expect. But then things get a little bit more interesting when we try and take a reference R1 and a mutable reference R2, and it's just not going to work, actually. And the reason it's not going to work kind of makes intuitive sense when you think about it. So there are some rules of references in Rust, and one of the rules is that you can have as many references as you want, but you can't have a reference and a mutable reference to the same piece of data. And again, that kind of intuitively makes sense, because if you have some piece of data and you take a reference to it, you wouldn't want some other chunk of your code modifying that reference kind of out from underneath you. And we are sad. Okay, so part of the sort of ownership model in Rust is to prevent dangling references, which are kind of a security vulnerability. And a dangling reference would be to return a reference to a piece of data that no longer exists. So this is us attempting to create a dangling reference. So dangle returns a reference to a string. So here's that. I guess I should have also emphasized that Rust has a return keyword, but it doesn't come up that much unless you're like exiting early from a function. So Rust is very like expression oriented. So, the last expression in a function is its return value. So I could say return, reference to S, but I don't need to. It's the last value. It doesn't have a semicolon, so that's the return value. But anyway, so we're trying to create a dangling reference here. So we are returning a reference to S, and of course S is destroyed as soon as that we exit that function. So us trying to create a dangling reference will cause the compiler to complain. Sorry, Ashok. The warning message, or the error message rather, tells us a way that we can solve it using lifetime specifier. We'll talk about what that is in a little bit. So I think I said all this already. So you can have either any number of references, or you can have one mutable reference. So like many other languages, we can also create our own types. This is done in Rust using structs and enums. So this is an example of us defining a struct called user. And user has these following 4 fields. And they can be, obviously any type. So structs are composite types the way they are in lots of other languages. Yep.
You have parametric types.
So glad you asked about that. Absolutely, you can have parametric types. We'll see that in a little bit, but yeah, in fact, I would say that's extremely, extremely frequently used in Rust code. Yep. Okay, so now we've created a type, we've created a user type, and we can create instances of that type just kind of using this notation where we have the type name and then curly braces, and then we populate the fields like that here. And then we can access elements using kind of the familiar dot notation that maybe you've seen in other languages. Sort of critically though, if we try to modify an element that, recall that the types in Rust are mutable by default or immutable by default, and that goes for types that we create ourselves. So this tells us, hey, we've not declared this as mutable, so it tells us how we would fix it. Which is the correct thing to do. Now, if we try and update a field in the user2 variable, we can go ahead and do that without any problem. Any questions? Yep.
Can structs have some fields that are mutable and some that are immutable, or is it just all or nothing?
That's a great question. The answer. So technically the answer is no. It's more like all or nothing, but you can solve that in kind of a different way with, there's something we're actually not going to talk about today, but you would solve that by having what are called public or private fields. So everything we're doing here is in the like main module, but like you could have your struct in a submodule and then declare in that module that only some of these fields are public, and then you keep the others private, basically. Yeah. Any other questions? Great. Okay, so I mentioned before that Rust isn't really object-oriented, but you can get some elements of that by defining methods on structs. So say we have a struct type called rectangle. It just has two U32 fields, height and width. We can then define methods using what's called an impl block. So this is an impl block for the type rectangle, and we're defining a single method here. That method is just called area, which takes self by reference and then returns a U32. So here we're creating an instance of a rectangle, and then here we're using the area method to create this area1 variable.
Oh, can I ask another question kind of related to the mutability in struct? Could you have, so what's the behavior for vectors? Because often when a vector is immutable, you can still change the elements of it, so that like doesn't trick the vector.
Yeah, so that's a great point. So Rust does allow for what's called interior mutability. Yeah. Yeah.
So like if the vector, if we define that this is a vector is immutable, it becomes like it can't grow, but all the elements inside change.
I think that is correct, yeah. Any other questions? Yes, Ashok.
So with defining methods using the implicit block, do all the methods have to be defined within one single block, or can you kind of define it somewhere else and then have it kind of add the method on?
Yeah, so the question is, if you're defining methods, do you do that all in a single impl block? And I think the answer, I'm pretty sure the answer is you can do it either way. It would be more conventional to have all your methods defined in a single impl, but yeah, I'm nearly certain you can do it either way. Yeah, I'm pretty sure. Ashok's the only person I know that brings a burrito to a pizza party. Okay. So in addition to structs, we can also create types using enums. So enum is short for enumerated types. These are basically these are objects which can only take on one of these couple values. So here we're creating an enum called coin, and it has 4 variants. So penny, nickel, dime, and quarter. And these are not really like fields. In fact, they're not like fields in a struct. They're more like variations of the coin. And this turns out to be pretty useful because we can do sort of interesting things. It's kind of like dispatching on the type. So let's create a function that that returns the value in cents of a coin. So we're going to pass it some coin type, and it's going to return a U8 integer. This, I think, is the first time we've seen the match function, which is, I would say, incredibly useful in Rust, and I think doesn't really have a nice analog in other languages that I can think of. It's similar to a switch statement or to a bunch of nested if-elses, but basically it says, take this thing, the argument coin, and then we're checking, is it a penny? If so, then return 1. If it's a nickel, return 5, etc.
It also looks like a hash table or a dictionary.
Just superficially, it has that appearance a little bit. Yeah, yeah, that's true. Okay, so our function basically takes a coin type and then returns an int.
By the way, are there hash tables or dictionaries in Rust?
There definitely are, and we'll talk about those in mere moments. Okay, so I think I said some of this, but oh yeah, so one other really nice feature of match, especially when it's used with enums, is if we let's try and rewrite the function that we wrote just a second ago, but let's forget to handle quarters. Rust won't let us do that, and it actually tells us how we can fix it. You can use this little quarter and then to-do macro, which will get around it. But basically, it wants to make sure that if we're taking in a type, we need to handle all variants of that enum. Oops. So match doesn't just work with enums. You can kind of use match with almost anything. So here we're taking in some number. So we're writing a function that says describe number. We take an I32 as an argument, and then we can do different things. So if the number is 1, we print 1. If it's 2, 3, 5, 7, or 11, we print a different message. If it's within the range 13 to 19 inclusive, we print a teen. And the underscore in Rust is kind of like the stand-in for anything. Yes, question.
Yeah, we have a chat question from Bill. He just wanted to know, does match allow you to do structural pattern matching?
Does match allow you to do structural pattern matching? So the question is, does match allow structural pattern matching? I think, yeah, the answer is yes. The answer is yes. That's a great question.
And then also that underscore to handle all other cases, can that still be used in the case of an enum or not?
Can the underscore be used in the case of an enum? I think the answer is yes. I'm pretty sure the answer is yes. I think anything means anything. Yeah. Actually,
When you had the coin example that you said you had to spell out all of the values.
So let's try that actually. Whoopsie. So can we use?
Like half dog.
Oh. Yeah. Turns out you can. Yeah. Good question. Okay, so there are two very special and important enums, and that is option and result. So the option type is super important in Rust because Rust doesn't have null values. So the way that we get around it is whenever there's an instance in which something might return a thing that's not actually there, we return the option type. So the option type has two variants, some and none. None is just nothing, and some is a thing that contains something else, where that something else is some type T, and T could be anything. So here's kind of what that looks like in practice. So here we're declaring some number, so this is an option type, and here we're declaring some string, and that's an option type as well. And we can look at the type of these, and we see that in the first case it's an option I32. In the second case, it's an option stir slice reference to a string. Working with option types is a little bit requires a little bit of sort of mental work. So if we have some int x is an I8, and then we have an option I8, and we try and do math, Rust will complain. And basically it's complaining because you can't, again, it wants us to be explicit, so we need to handle that explicitly. And there is an unwrap method on the option type that handles that. So unwrap is good and bad. It's good in the sense that it lets us do the math we want to do. So we can go ahead and run that. Oops.
Conceptually, why would I want to work with options?
Conceptually, you would want to. It's basically the mechanism to avoid having nulls in the language. So we want to use option because if we don't use option, then there's no obvious mechanism of indicating or of forcing the programmer to indicate the potential missingness or the potential null or the potential absence of something.
Either the I8 or null. It's like a union of that?
Yeah, that's right. It is kind of like a union type. Yeah. I don't know why this failed. Does anyone know why this failed?
Why is
Oh, yes. Okay. So the the unwrap method is good and bad. It's good in the sense that it gives us access to the data that the option type contains, but it's less good for the reason that we see here, which is that it crashes your program when you call unwrap on a none type. So what is actually more common, and I think what people might consider like the according to Hoyle approach, is to actually pattern match using the match keyword to unpack whether or not there's data in that thing. So that's something that you see a lot in like, library code in Rust. Yeah, this is the same thing. So yeah, so this would be maybe a more typical thing. So we take, so we're writing a function that adds 1 to whatever you pass it. You pass it an option I32. We then check, so match is going to check if it's a none, then return none. If it's sum, then take the I and return sum I, or sum I plus 1 rather.
And then for the built-in methods, like, are the built-in methods doing this for you?
Are the built-in methods?
I guess no, because the class didn't have it.
Yeah. Yeah. So this is, this is unpacking the sum type, and then we're just doing some math with it, and then returning another sum.
Yeah, so, but more generally, I guess you could override the operator class to always do this, right? But the natural class operator.
Yeah, so that's a good question. So the question is, it would be nice if you could overload the plus operator to handle like the option type in kind of a way so that we don't need to unpack it. I would say it would not be so nice, actually. Because again, we want to be explicit about handling missingness. And I think that you can overload operators in Rust, but I think they probably chose not to do it because it kind of like, it would be too magical, yeah.
Can you pass a function to some?
Say that again, please.
Pass a function to some?
Can you pass a function to sum? Yeah, I think so. I don't think there's any reason that wouldn't work. Yeah, functions are like just a type in Rust, so yeah, I think that should work.
Is there any other keywords for options? Is it always sum?
So option has only 2 variants. It's sum or none. Yeah. Yep.
Is this how exception handling is done in Rust, or is there a different way to that?
We will talk about that very, very shortly.
For example, if I have like 10 different options here, is there a way to avoid kind of like chaining all these matching?
I'm not sure I understand. If you have like option I32, option F64 or
So
something.
for example, if X is an option, right? Y is an option. If I have some 10 things like this, I want to do some operations to all of them. Then
Yes.
you need to kind of like chain all these matching things, right? Is there a way to kind of do that?
Yeah, that's a great question. So the question was, if our function takes not just a single option type, but takes a bunch of different option types, do we need to like handle those all individually? I think the answer is yes. I'm pretty sure it's yes. And that's where some people get into using unwrap, because yeah, that would make the code a little bit more terse, although still pretty verbose. Yeah, that's a good question. I think the answer is you still need to handle those individually. Yeah. Any other questions? So in addition to unwrap, the option type also has this nice convenient method called unwrap or. So if it's going to unwrap and return a null, we can specify a default value. So here we're saying we still want a function that adds 1 to a thing. It still takes an option I32, but now we try to unwrap, and if it unwraps to a none, we default to 0 and then add 1. Yeah. So that works with sum 137 and also with none.
Why was it able to do the sum and the plus 1 with
Yeah, so why? So the question is, why was it able to do the sum 137 plus 1 without casting it to? Is that the question?
Yeah, like without casting 1 to being an option type instead of just I assume that.
Well, so yeah, okay, okay. So I see. So this expression returns an int. Yeah. So yeah. Good question. Anyone else? Okay.
But did it work when we had it without unwrapping? No, it hadn't worked.
It hadn't worked. Yeah.
It gave us a type error.
Yeah. So if we try and do this without unwrapping, and again, the error messages in Rust are just. So the other kind of important enum in Rust is the result enum, and this is basically how we do kind of error handling, Ashok. So it's going to ask us to kind of distinguish between recoverable and unrecoverable errors. So we want to use result when it's something that we can recover from. You obviously can't recover, like if you're out of memory or something like that. That's not an instance where you can recover. Oops. So, for example, reading from a file that doesn't exist. Oops. It's going to panic and then give us this message, problem opening file, blah, 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 blah. Okay, so here is an example from the Rust book. Whoops. So this is a little guessing game that we try and guess the number. So the number is between 1 and 100, so let's guess 50, 75, 3. Great. So this this little program is a nice showcase of some of the stuff we've talked about already. Oh, you really can't see that so well, huh? Okay. So these are some of the constructs that we've already talked about. So this is us loading some libraries. Then we have a main function. Every Rust program has a main function. We then create some secret number, and then we have this is basically a while loop, except there is no terminating condition. So I'm not actually sure what other languages have a loop construct, but this is basically like while true. So this is a loop that will run until we call break. And this is where we do our guessing. So all this stuff is handling the input. So we allocate some mutable string that's going to hold our guess. And then we read from standard in and then put that in guess. And then we try and make sure that guess is castable to U32. And then we compare guess to secret number. And this is kind of an interesting thing that I guess I don't actually know how well you would do this how you would do this in other languages, but you can import. So we're using the ordering trait, which allows us to do this little comparison. So this .cmp is going to return an ordering enum. So it could be less than, it could be greater than, it could be equal to, but you get the idea. So this is another example where like the match block or keyword is like super, super useful. Any questions on this stuff?
Is there some made-up programming at work with this match thing? Because I saw, like in dictionaries, you can attach like an expression, like a print something when you get this value from an enum or whatever.
Yeah.
Is that some meta programming at work in the back?
I don't actually know. Yeah, I don't actually know what it does under the hood, but
Seems like it. Like
potentially,
it's
yeah.
expression, and then you kind of like execute it.
Yeah,
The command reminded me of kind of like
yeah,
macros. Meta programming. That's something you can't do in a dictionary.
right.
So I like match.
Me too. Camilo?
Yeah. I don't remember if you already mentioned it, but passing parameters to a function, by default, is it by value or by reference?
Yeah, that's a good question. So the question is, when you pass arguments to a function, is it passed by value or passed by reference? And it is passed by value. Yeah. So that's why, like here, we're using the ampersand here to say we're taking a reference to secret number, not secret number itself. I think it actually wouldn't matter here since it's an integer, but great. Oh, sure.
When you write okay or error, is that just a syntactic trigger for like result double colon okay or result double colon error? Or can you do that with any enum that's in your scope?
So the question is, when you write okay,
Like if I were to, when you initialize an okay, or when you initialize a sum, you just write sum instead of option double colon sum.
yes.
Whereas for other enums that you were constructing, it looked like you were using that double colon syntax.
Yeah, that is true. Yeah, that's correct.
So that's only true for built-ins?
I think that is only true for built-ins, yes. Although I think you could also do it for your own like user-defined types if you. Maybe that's not true. I don't actually know, but I think you might be able to do it for user-defined types. I'm not sure. Maybe that's false. I don't know. I look forward to finding out. Okay, so let's talk quickly about some common collection types. The vector type is one that comes up a lot. Vector is kind of a, it's a one-dimensional type that stores a bunch of data in kind of a contiguous array. So if we try and, whoops, let's make that a little bigger. If we try and allocate V1 as a vector of I32s and then try and append to it. So vectors are growable, but only if we declare them as mutable. So we need to say let mute, and then we can append to it. This would be kind of a more common way to initialize a vector. Usually we have something we want to put in it. So this little vec exclamation mark macro is kind of that's a very kind of traditional way to allocate a vector with some literals. To access elements of a vector, we can use kind of the familiar square bracket notation that you would use in any number of other languages, but that turns out to not always be an okay thing. So here we have a vector v, and we try and get the 100th element of a 5-element vector, and that will actually cause the program to crash. So the more frequently used I don't know if it's actually more frequently used, but the probably more advisable is the get method. So vectors have a get method, which allows us to try and get the element in the nth position, and that works. But as you might guess, it doesn't actually return the value. It returns an option of the value. So here we'll be returning it'll be returning none.
The little exclamation point that infers the type, is it like that is pretty clearly all ints, but if you have one as a float, does it still infer it, or no?
So the exclamation mark actually doesn't infer the type. The exclamation mark is what Rust uses for macros. So that's why the print line is a macro. So the type inference, I think, happens automatically. and to your question, if we try and make this, I think it'll complain. Yeah.
So if you had the vec without the exclamation mark?
I think that's probably just going to say we don't know what vec is.
Oh, I see. That's a macro, not a type.
Vec is a macro, yeah.
Capital vec.
Capital vec is a type, yeah.
Does it have a constructor like in normally in other languages?
Yep. So, and that's actually, what we did here. So, this is saying, create a new vec, but then you'll note that here we had to do the type annotation because it doesn't, unless we tell it, it can't infer the types of something where we haven't put anything in it yet.
And could you
Oh.
have initialize, so on the new you could have passed the 2 and the 3, right?
I don't know about that. I think maybe the answer might be no, actually. I think there's a different syntax for that, I believe. Although actually now, yeah, that's funny. It works without the type annotation. I think because it can see that we're only pushing ints into it. That's kind of interesting.
Ahead of time?
Okay. Oh, okay. Yeah. So this is another kind of idiosyncrasy, although I guess it's really a feature of Rust. But so here we're allocating a vector, and then we're taking a reference to the first element of the vector, and then we try and modify the vector, and Rust doesn't let us do that. And again, I think this is the notion of having a reference and a mutable reference. So if we want v to be mutable, we can't have a reference at the same time as a mutable reference. I think that's why this breaks. This is not that interesting. Oh, okay. So you've seen us create strings where we say string : : from, and then an actual string literal, and that's kind of for an interesting reason, which is that the string type in Rust. So there's only one string type in Rust, which is actually this stir slice. And whenever you see it, or not whenever, but you'll typically see the type annotation as a reference to a stir slice. And that's what's built into the core language, whereas the string type with, capital string is actually part of, the standard library. And it's actually more similar to a vector in the sense that it's growable, mutable, and it's heap allocated. So we can modify a string type. This is what we saw before, and the reason is that string does not implement the copy trait. So the way we got around this before is by saying .clone, and then that would be fine. Whoops. And that would be fine. But we don't have to do that for those types that implement the copy trait. So the like built-in core language types like int, float, all those, they will implement the copy trait, which means that this kind of reassignment, it makes a copy of the original n, so that we still have the ability to refer to that. Camilla, do you have a question?
Yeah, is it possible to index the string?
Is it possible to index to a string? Yes.
Is that a char, or is that a
If you index into a string, it does give you a char. Yeah.
The vectors implement the copy trait?
Yeah, that's a good question. So vectors and strings are actually very similar in the sense that they're both like, there's a they're basically pointers. There's a they're heap allocated pointers essentially. Yes. That's what we just said. I think I'll skip this. So this is what ownership movement looks like. It's basically saying, okay, now V doesn't own the data anymore. The data's on the heap, and now V1 owns it. And this is what we already did. And then here, this for those types like I32, F64, etc., that do implement the copy trait, we don't need to worry about clone, or we don't need to worry about the heap. It's all stack allocated, and we're just making a copy on the stack. Yeah, so clone is the way we get around it with vectors. Okay, we're about to go over on time. I will go for, let's say, 5 more minutes, and then we'll call it a day. You're welcome to the slides, obviously. But yeah, some other collection types you might want to use. So the hash map type is extremely useful. This is the kind of dictionary type in Rust. So we can put stuff in it. The functional language features in Rust are quite nice, actually. So we can define closures using the double pipe syntax. So this is defining a closure called equal to X. And this is going to check basically if some argument that we pass it, so our argument is Z, is it equal to X? And here is yes. So if we try and do this with a function, it's going to complain, and actually, again, the error messages are super useful. So the nice thing about closures is they close over their environment. So equal to X has access to the variables in the scope in which it was defined. So if you'll note, we're not passing X to equal to X as an argument. We only pass Z to it. But because it's a closure, it has access to X just by virtue of being in the same scope where we defined X. And this doesn't work with the function, so here we describe a function called equal to X, and then try, and it's going to complain basically because it says, hey, I don't know what X is. Any questions on that? Is there another talk here at 1? Nope. Okay, great. Rust also has iterators, which are quite nice. You've probably seen these in other languages. Rust has 2 kinds of iterator methods, though, and I think this is something that's not super explicit in other languages. We have consuming adapters and iterator adapters, and those behave slightly differently. So the sum method is a consuming adapter, so we take some iterator and sum all those values and then get some number. So that is a consuming iterator, and it consumes it because it basically takes all the contents of it and then does something else with it. Map is an example of the other kind of iterator or method on iterators, which is a iterator adapter. So if we run this, hasn't actually done anything. So Rust is lazy, so it has given us back another iterator. If we actually want to get the result of that, we need to call collect, which then gives us back, the result of this mapping. Any questions on that? Great.
And the dot notations with daisy chain functions, is that for all things, or?
So yeah, that is for all things. So this is a really common kind of pattern in Rust, is basically to chain the method calls like this. Yeah. Okay, generics. You know what? Okay, so Rust has generics, and what that looks like is probably the way you've seen generics implemented in other languages. But suppose we want to write some function that takes in some array and returns the largest value of that. If we want it to be kind of, let's do the more straightforward example. We would write a separate function for i32, a separate function for chars, etc. But it would be nicer if we could do that in kind of a general sense. So here's an example of this almost works. So this is a function that is generic over t, where t is some type, and this is kind of the same behavior as we saw in the other ones. And again, it almost works, and we will make it work in the near future. You can also have generic structs. So I think someone asked a question about this. Yeah. So here we create a point type, and that point type has the generic parameter t. So x and y are both of type t. So if we go ahead and run that, it creates two structs, one with integer, one with float. If we try and do that where x and y are of different types, it's going to complain because we need both x and y to be of type t, so either they are or they aren't, and here they aren't. Is that a question or a stretch, Isa?
It's a stretch.
Great.
But I could ask, but I suppose you could have T1, T2.
Yeah, so you could have... yeah. Okay, so traits are interesting. So traits are, again, we said that Rust is not object-oriented, but there are instances in which we want to define shared behavior, and in Rust that is with traits. So there's no inheritance or anything like that, but traits are the method of, we're not going to have time for this. I will stop there. Thank you all very much. If you're interested in the slides, they're on our GitHub. Have a lovely weekend.